James, it's interesting, I love your guys' company and what you're doing for people and for clinics. And so I'd love to just hear more about the name Voxel and how you came up with this business.
Yeah, sure. It's been in the business now of dentistry for um 20 years. So let me restart my video. Okay,
There we
there
go.
we go. All right. But been in the business of dentistry for 20 years now, and just from the very early days, when CBCT first came out, I was really just enamored with the 3D technology, and so I started my first business back in 2008. Was an imaging center, and we were heavily involved in 3D CBCT and planning, and then I ended up working at Carestream, running sales and marketing for the orthodontic department, and I was doing some lecturing, and it was just like every time I would do these CBCT lectures, I was talking about, resolution. So voxel, which a voxel is nothing more than a three-dimensional pixel. So when we're talking about how good is the resolution of a machine, we're talking about, what's the voxel size. So it was just a word that I used a lot. And then when I actually started this company, back in late 2016, it was just, I was like, man, no one still has used the word voxel. And I still think it's a cool term, especially with what we're doing with, we're going to focus on, 3D technology. It's a great term to use. So there you go. That's how we ended up being Voxel Dental.
I love it. It's so creative, and you guys are doing a great job over there. So let's
Thank
go
you.
ahead and just dive in since we're a few minutes late. So today's hosts, I'll go ahead and introduce everybody, starting with myself. My name is Michelle Rosas. I'm the VP of Business Development for Full Contour. I have been with Full Contour for a little over 7 years now. I've done a lot of different roles over the last 7 years, but today I really help labs and clinics get onboarded with digital strategy, helping to grow and scale their labs and clinics. And so if you guys have any questions about design, CAD CAM, anything like that, I'd love to have a conversation with you and just you can pick my brain. I don't know all the things, but I know a few things, and I'd be happy to share what I do know with you. And then today joining me is Dr. Gabriela Nelson. She is our clear aligner specialist and DDS on the Full Contour team. Dr. Gabriela, why don't you just spend a minute giving us your background and a little bit about you?
Thank you so much, Michelle. Hi, everyone. My name is Dr. Gabriela Nelson. I'm a general practitioner and currently with Full Contour, I'm providing clinical support to labs and doctors. Also, I've been working with the clear aligners industry for around 6 years. Please feel free to reach out to me if you have clinical questions, questions about movements, questions about the platform, anything that I can support you with Full Contour. Thank you.
Awesome. Thank you, Dr. Gabriela. And also joining us is James Bonham. He's the founder and president of Voxel Dental. You heard a little bit about his story on how he created Voxel, but James, why don't you tell us a little bit about yourself?
Yeah, just kind of pick up from where I left off there. I guess been just loving and very passionate about digital dentistry for many years now, and had quite the journey. Worked for a couple of the big corporations. Had a few entrepreneurial stops as well, including 3D imaging center. So and then outside of that, when I sold the imaging center after 3 years of that, I bought a lab. That lab was then acquired by the second largest orthodontic lab in the country, and had a great 5-year run, in the laboratory business. That lab, we were the second lab in the country to own a 3D printer. So
Wow.
we were in it from the very early days, and and it was just some fun, exciting growth. So when I decided to sell my participation in that lab to start Voxel, it was really just with the idea, the passion of the way things are going. The whole idea is, we want to help doctors bring these laboratory workflows into the practice because they can be so much more efficient, and turn things around faster, more profitable, all of that. So we started back in 2016. We were probably the first 3D printer dealer in the country. And then of course it's just evolved into CBCT and all digital workflow. But we pride ourselves with the people on our team and the know-how, and and how we approach our doctors, which is in a true consultative manner. We're passionate about helping doctors be the best, most efficient practice they can be through digital technology.
We'll talk about right time and right place. I mean, chairside printing and is just exploding. I mean, we're seeing it all over the country. So we're really excited about what you guys are doing and the information you're going to share with everybody today. So jumping into the learning objectives, we have a ton to go over and it's all just jam-packed, very exciting stuff. So we're going to go over what cases are best for in-house clear aligners and then how a movement philosophy affects the predictability and cost of your cases. So just more of the clinical side of things and things that you need to consider when you're taking on in-house clear aligner treatments. And then we're going to pass it over to James. He's going to go over the different 3D printing technologies because there's a lot to know out there and it can get very overwhelming. And also what solution is right for your practice and what you're going to be printing. And then we'll end with some post-processing aligner fabrication tips and tricks. We want this to be fun and interactive. If you have questions throughout the webinar, put them in either the Q&A down at the bottom or the chat. We'll be monitoring those and we'll make sure and answer all of your questions either during the webinar or we'll have time at the end for Q&A. So briefly, today's webinar sponsors are Full Contour by 3Shape and Voxel. Just in case you're not familiar with those two companies, we're going to do just a brief introduction before we get started with our actual content. So Full Contour by 3Shape is a global design service. All we do is design. We don't do any manufacturing of any physical products. So you give us an STL file, we would do a clear aligner treatment plan and we would give you back the print ready STL files for your printer. We have 2 design centers, one in Costa Rica and one in China. So that way we can serve you with design 24 hours a day, 6 days a week. And we have 2 support locations to support you in multiple languages and different time zones. We do offer a wide range of design indications, everything from fixed crown and bridge to ortho, guided surgery, and removables. So if you see anything in this list that you're interested in or need help with, please don't hesitate to reach out. We'd love to have a conversation on how we can work with you, what the workflow is, and what files are needed to get started. So that's a little bit about Full Contour Design Services. Pass it over to James just to give a brief overview on what Voxel does.
Yeah, thank you. It's kind of similar. It's that we're very focused, just like you guys. You said, you guys at Full Contour just do, digital design. We're not your typical supplier. We don't do, gloves and cotton rolls and, just basic supplies. The only thing that we handle is digital equipment and how it workflows in the practice. So, quick overview of, just consultation, X-ray, scanners, robotics, all that stuff. But how we do it, we're a little bit different. You're not going to see us advertise and market a whole bunch. We really are just educationally focused. These are images from our facility, in Magnolia, Texas, which is basically just north of Houston, near the Woodlands, Texas. But we do a lot of traveling events. We do a lot of hands-on courses. It's all about, just like our slogan says, high-tech equipment, but high-touch approach. And that's who we are at Voxel.
Awesome. Thanks. The first time I saw James speak, I was just blown away by how much you knew on 3D printing technology. And I learned stuff. I was like, I had no idea. I had no idea that there was different printers for if you wanted to do dentures or clear aligners or splints. And so I just thought, what better way to bring you on and just share your knowledge with everybody who's looking to get into in-house fabrication. All right, let's jump in. So first, we're going to start with case selection for in-house clear aligners and why this is so critical when you're going to do a treatment plan for a case that you're going to produce in your own lab. So I'm going to pass it over to Dr. Gabriela Nelson. She's going to take us through all the clinical things around in-house clear aligners.
Thank you so much, Michelle. So yeah, as we were mentioning, today we're going to focus more on in-house cases. At Full Contour, we offer anterior treatments, we offer full arch treatments, we can do any complex cases. However, basically today, we're going to focus on anterior aesthetic movements, such as crowding, mild spacing, or mild shift that will be less than 2 millimeters, also anterior open bites or mild deep bites. So these type of cases that I'm showing right now on the picture are considered treatable. So we're gonna go through different categories. The first one will be relapse or refinement cases, in which this example that I'm showing on the picture is perfect because this was a patient that went through braces and wires and he got premolars extractions. So after this braces treatment, he had a relapse. And this is when we can take advantage of that, because relapse cases can take only smaller trays, such as between 2 to 5 trays. The level of difficulty will be easy, and the revenue potential will be around $1,000. So minor treatments will be perfect for in-house aligners. Now we're going to jump into the second category, which is hybrid orthodontic therapy. This is a great opportunity for in-house aligners because the combination between clear aligners and braces achieves optimal results in a shorter period of time. So by using this for only between 2 to 5 trays as well, the level of difficulty will be easy. The revenue will be around $1,000. And I know that James has more experience about hybrid cases. He's been seeing like a ton of this. So maybe James, you want to jump into this one?
Yeah, thank you. There's really two types of hybrid approaches from what we see with our customers. There are those that um, I- you can call it hybrid treatment, but it's really more of a less just active retention, where you see it all the time, where doctors are removing braces. We're at the end of treatment. And things look just perfect, but you take the braces off and you're just like, ah, man, it's just, there's a couple little tweaks that I would still love to make. That's the perfect situation for, when you have an in-house 3D printer and you've got a great, minor tooth movement service like Full Contour, where you can just quickly and easily make, 3 to 5 trays, whether you call them aligners or it's just active retainers that you give in succession to the patient to wear maybe 1 week at a time, and really just dial in that case. That's one way to consider hybrid treatment. But we also see, we have a lot of clients, hundreds and hundreds of particularly on the orthodontic side, orthodontic clients that actually take this hybrid approach, where they're going to do all the major movements, the leveling and aligning, with the orthodontic braces, and then it converts into, once the difficult movements like up down, torque movements, some things like that brackets just do a really, really good job at. You can then transition and maybe get someone out of braces sooner so they can make, a graduation date, a wedding, or whatever. So it's a great opportunity to take this hybrid approach, that even if you're doing orthodontic braces, to maybe take them out of braces 3 to 4 months earlier, and then wrap up that case with aligners, and you have a much more aesthetic option to offer your patients. So we have doctors that use the hybrid philosophy in both those scenarios.
Awesome. Thanks for that.
Thank you, James, for that. If we move on with our third category, will be cases for restoration, in which they are great for minimal movements, maybe a case in which requires veneers, or maybe just maintain the space for an implant and then placing a crown. So simple and highly predictable movements. Even though their level of difficulty is still easy, sometimes the number of trays can increase a little bit. So it could be around 5 to 12 aligners, and the revenue potential for these type of cases will be around $2,000. To move on with mild to moderate cases, which I feel is some of the cases that we see every day. These mild to moderate cases on the clinical scope, we are looking for cases in which we have a class 1 patient that not requires like an anterior posterior movement. Also cases in which we have mild to moderate crowding and spaces, and also cases in which we might need any type of pre-restorative movements. So the only thing with mild to moderate cases is that the number of trays is going to increase because, as we need more movements, the amount of trays is going to increase. The level of difficulty as well will move to medium, and the revenue potential will be around $2,000 and $5,000. Other thing is that we need to go very straightforward with our patients in telling them that when we have more aligners and we have more movements, we need to consider that we might need a mid-course correction or refinement. So it's very important that we clarify with this with our patients, because the cost can increase also. Okay, and to go into our comprehensive cases, which is our last category, the comprehensive cases, I try to place this type of example in which we have a DBI patient. So it's important to know that we require more aligners in order to be able to level the curve of SPE, or maybe do anterior intrusion. If we need to do extrusion of the premolars and molars as well, this will increase the number of trays. Also, the level of difficulty will be difficult, and the revenue potential will go up to $7,000 or more. Other thing that we need to take into account is that if we are doing in-house aligners and we only have one tech that is producing all these models and printing all these aligners, the cost will be higher. So this is the moment in which our recommendation is to outsource this and do it with someone else. It's not that we cannot do it at full contour. As I mentioned at the very beginning, we just want to stick to the in-house aligners, and comprehensive cases will increase the cost, the difficulty, and number of trays in all the ways.
I'm going to just chime in here and just say that, as Dr. Gabriela mentioned, full contour can do the design and you can do the manufacturing of these. But the time it takes to print, say, 50 models, you got 25 aligners or more per arch. And then because there's so many trays, you have a much higher probability that you're going to need a refinement or 2 refinements. Patient gets tired of wearing the aligners 22 hours a day, so compliance goes down. And some of those movements are just difficult to make happen, right? And so then you go back to the patient and say, hey, you're going to need another scan, a new set of aligners. It's going to cost you X amount more. Patient gets frustrated. You get frustrated, right? So when you use some of these big aligner companies that can do manufacturing for you, you can buy one of those comprehensive packages that come with unlimited aligners for an all-in cost, right? And that might be a little bit easier for you to manage for the patient, for your own costs, also for your own sanity of not having to keep track of all those models and aligner trays and keeping them all in order. So it's just our recommendation that you avoid comprehensive cases when you're producing in an in-house laboratory.
Yeah, and Michelle, if you don't mind, I'll comment on that. I'll back that up 100%, just because we're pushing 2,500 printers sold in orthodontic offices at this point. So we've worked with quite a few orthodontists, teaching their staff how to do all these things, and we've always kind of said that cutoff is around me. It can get too overwhelming, and it can be too much of a bottleneck on the production side. And that's, we're going to go over some tips and tricks on the production at the end of towards the end of this presentation. But you want to, staffing's one of the more difficult things in dentistry right now. So you want to be mindful of that and not to overwhelm the staff with having to produce too many trays.
Absolutely. Thanks, James.
Absolutely. Thank you, James. Yes. So this is an overview of all the different categories that we just saw. We have the number of trays, we have the level of difficulty, a cost estimate, the revenue potential, but I just want to highlight again how we would like you to know that relapse cases, hybrid cases, cases for restorations are like a yes, and in-house aligners. However, we are not saying that mild or moderate are not possible or that comprehensive are not, but again, sticking to the cost estimate and the revenue potential, we would love to go with these type of 3 categories. Also, your cases succeed will be based on the printer, on the material, on the labor cost, and how much you're willing to sell those aligners to your patients.
Yeah, all the cost estimates and revenue potential, guys, they range wildly depending on a lot of different factors. So these are just kind of like in general, this is what offices tend to sell these for, and then also what their cost side is.
Also, I wanted to touch base with in-house retainers, which is another great idea of going with this printing. So these will be $10 or less on in-house manufacturing cost. Also, If you do in-house retainers, this will increase your revenue by 300 to 500 per case. Remember that after every single treatment, we need to go under retention so we can keep the current position and the goal will be maintained. So this is a great opportunity to sell this option to your different patients. Also, we have the retainer guarantee program or subscription model. We have been hearing that most of the doctors are using this. And I know that James as well is like really involved into this. James, do you want to talk a little bit about this?
Yeah, this goes back to my commercial lab days, where the lab that I was working at, had a product that was geared around a retainer program. Invisalign does this as well with their Vivera program, but it's the fastest, easiest way to pay for this equipment, in a very short period of time, as far as a 3D printer and in-house thermoforming. Because I mean, just the fact that the way that looks like is you get to end the treatment and you get a retainer that's part of your treatment. But we also have this new program where we can, basically a retainer guarantee or retainer assurance, where you're giving them multiple retainers. You're giving them the retainer, a backup retainer, and a copy of that 3D printed model. The whole idea is that you can continue to give new retainers and maintain that smile, but never have to have chair time again. So basically, if the day they lose or break or whatever that initial retainer, they go to the backup retainer. They go underneath the bathroom cabinet. They get the retainer out of the box that you give them. It also has the 3D printed model in there. They drop that by the dental office, and the next retainer is made. And maybe that next retainer is only $20. But as long as there's no tooth movements, as long as that we need to recapture, as long as there's no major dental changes, you can retain that smile for forever, very affordably. But we're talking about, it's very, very inexpensive to do this in the practice, and it's a great service, but it's a great revenue builder for this as well.
Thank you, James, for that. Well, just as a summary, treatable cases will go from mild to moderate movements. Mainly non-treatable cases will be cases that require midline shift over 2 millimeters, skeletal cases, maybe class 3 cases, or cases with posterior crossbites of more than one teeth. So we know that these cases not only require more trays, but also they might require additional techniques to be achieved, such as maybe detail pliers or the use of elastics. So let's keep in mind all the treatable ones. And to move on with the movement philosophy, remember that the movement philosophy, it's going to determine how much movement you are willing to do from the start to the finish of your treatment. How much movement will happen per aligner and the movement of all the treatment per se. So we need to keep in mind several things. One will be some of the factors that might affect the number of the movements, such as age, maybe medications of the patient. It could be also the patient's oral hygiene, also the periodontal status of the patient. So all those things are factors that we need to take in consideration. And also, last but not least, other thing that we need to take in consideration is the way that we want to move or treat our cases. If we're thinking about using distalization movements, or maybe we're thinking on doing movements in block, or it could be round tripping. So those type of movements as well are going to affect or not affect the number of movements in your case.
Yeah.
So go ahead.
Sorry, Gabriela. I was just going to say, we often get asked by labs or doctors, they get a case back and maybe they were hoping for 7 trays and it was 12. And they're like, oh, why is that so much more than what I was hoping? And it all comes down to how much movement per tray and the sequence of how you move the teeth, right? If you do round tripping, it's more trays. If you do sequential distalization, more trays. If you slow down the movements, more trays. So the movement philosophy is so important in the outcomes, and then how you get from point A to Z. So
Yeah, it's important as well to understand that the chart that we are sharing with you is the standard movements per aligner, but this number can be adjusted. It could go down or it could go up. However, we need to be aware of the possible consequences that those adjustments might bring to your treatment. So also what the patient will be feeling, if it will present mobility or pain. So all those things need to be very important while you're thinking on the way of the movements that you're going to treat your case.
Yeah, and also the um, how aggressive are we going to get with IPR, with individual cases? But that's what a lot of people don't necessarily consider when you look at a case and say, oh, this is very minimal movement. This is only going to take 5-6 trays, but without necessarily realizing that sometimes you have to move a tooth out of the way so that you can then rotate the tooth next to it and then move that tooth back in. So that's why in the ortho lab world, we would have that same response, Michelle, where just not a true understanding, I guess, of how many trays particular situations can create.
yeah, absolutely.
So I wanted to highlight that we went over what cases are best for in-house aligners. Also, how does the movement philosophy affect the predictability and cost of every single case? So I just wanted to highlight that, as Michelle mentioned at the beginning, full contour is just a design service. So if you are thinking about going with clear aligners treatment planning, we are happy to assist you with that. We do not produce any physical trays. However, we can provide the design and the STL files to print them out. So we are sharing with you right now what we offer, which is a 3D viewer and a tooth movement overview. Also, this will tell you when exactly you need to do IPR, when and where. Also, when and where we're going to do placing the attachments, for example. So we offer this 3D viewer and you can interact with it. It has several features. So it's important that you know that this is available for you. And in addition, you can share the final outcome with your patient. This final outcome can be shared through a link. So in the patient's comfort in their house, they can open the link in their iPhones or tablets or computers, and they're going to be able to share this final outcome with their family or friends and get excited about the treatment.
So we got a great question, and it's our fault for not being more clear on some of these definitions. So Dr. Gabriela, we got a question asking, could you tell us what IPR is?
Oh, I'm sorry. Yes. Okay. So IPR is the reduction of the enamel. This will depend on what you want to do on your case. If we need to create more space, as James mentioned, if we need to rotate in a specific tooth, then we need to create space, we will do it with IPR. We can also add IPR if we want to improve, for example, class 1 cases by doing a little IPR. There are like tons of ways of using IPR, but yes, mainly it's just doing a reduction of enamel.
So it's like it's filing in between the teeth, basically.
Exactly. You can decide, of course, we're going to provide the number of the amount of IPR that you are going to create, but then you can decide the amount that you want to do on the mesial or on the distal of that reduction.
Perfect. And Miguel, if you want more information, Dr. Gabriela put together an amazing training video all about IPR and the different tools and all of these things. So at the very end, there's going to be a QR code that you can scan to get more information from us. So if you just fill in your details, Dr. Gabriela can reach out and send you the link to that YouTube video.
For sure. Yes, on that video, we have all the information on how to perform IPR and all the different options that you have right now in the market.
Perfect.
Okay, so just wanted to touch base on this part of what we provide as full contour design for in-house aligners, the treatment planning with the proven movement philosophy. Also, we will provide to you the print-ready STL files, completely customized with the ID tag that you would like and the tray number as well. With the 3D viewer for doctor review and patient review, you can share the link with your patients. And also, we provide a free refinement design for each case.
Perfect.
And wrapping up with our recommendation is to always focus on the 3 Ps. So the 3 Ps, when you are considering in-house aligners, we're going to ask ourselves, is this outcome possible to achieve? Is it predictable? And if it is predictable, is it possible to do it? Are the movements going to happen as planned? Will these require more aligners or more cost? And most important, the final P, is it going to be profitable for my dental practice to make money? So this is our recommendations just to wrap it up. And I'm going to pass it over to James. He is going to go through an overview of different 3D printing technologies, also what solutions are right for your practice, and a post-processing aligner fabrication tips and tricks. James, thank you.
Yeah, thank you very much, Dr. Gabriela, and thank you, Michelle. To start is just with talking about some of the things that we do, because this presentation is very condensed. I can give the same presentation to a crowd and it can be 2 hours as well, just depending on how deep we want to go. So please remember that if you have additional questions, to please, reach out, and I'm definitely interested in diving deeper with anyone who wants to go deeper. But with some of the things that we do, the fact that we are just focused on, at Voxel Dental, we're focused on, digital workflows, and where we actually started the company, because I came from an orthodontic laboratory, truly the basis of the company was, putting a 3D printer into the office and teaching the office how to bring that workflow in-house, basically exactly what we're talking about today. So we carry all those products that help us do that, from the orthodontic standpoint, anywhere from the x-ray machines to the scanners to the 3D printers, to wire bending robot, which is a whole nother topic for, fixed lingual retainers. It's a new technology that we just brought to market, as well as, we are the exclusive provider for some thermoforming plastics here in the US. So that's one of the things that we're going to discuss today at the end of the presentation, on how do we process those thermoforming plastics. So let's move on to, not only are we going to talk about 3D printers, but we're going to just highlight some workflows. We're not going to dive too deep into workflow today. Really, the goal is to help you guys decipher the different technologies, so you have a deeper understanding of, how 3D printing even works, and then understand maybe, the different brands that you see marketed on the market today, and hopefully you get an idea of, what's the right fit, because at the end of the day, there is no such thing as a perfect printer for everything. Some of them are just better at some workflows than others. And, that's kind of why we're here. We like to help doctors differentiate the different printers and really make sure it aligns with their goals. So the current printer options that we carry, we carry Sprint Ray, and have since day one. We were one of their very first, I think we were their first dealer. But we also carry the Desktop Health line, the Asiga line, and the FlashForge 3D printer line. And each one of those lines that we carry for a reason. And that's what I'll kind of try to explain to you guys today, because for us at Voxel, it's all about having options, being unbiased, and helping you find the right solution. But let's dive in a little bit to, what printer do I buy? But before we kind of really can talk about that, we need to understanding, I'd like for us to understand the different 3D printer technology basics that are out there, the resins that are available with these different 3D printers, and then really truly understand what my options are. And like I said, we don't necessarily have an opinion for everything, but depending on what your workflows want to be, I do have an opinion. So that's kind of what we want to help you guys figure out. So when it comes to 3D printers, one of the most common misunderstandings that people have is they don't understand the difference with the XY resolution and the Z-axis resolution or layer height. So for the basic understanding, the XY resolution is actually basically how fine of a resolution, whether it's a projector or a laser or an LCD screen or whatever the light source is, how good is that resolution? How small of a voxel can that create? Remember, when we talk about voxels and pixels, basically it's just how small can that light shine to create a really, really smooth surface, a really, really high detailed appliance or model. But that's different from Z-axis. Z-axis is actually, you hear most people talking about, well, I'm printing at 50 microns, or I'm printing at 30 microns, or I'm printing at 100 microns. The Z-axis is what they're referring to there, and that's really nothing more than the layer height. So the way 3D printing works is we start with a foundation layer where you've got a build plate and a vat of resin, as far as vat polymerization printing, and we're literally just the software is breaking that down into slices, like you can see on this model here. And then we're just printing, or we're curing a layer of resin, layer upon layer upon layer. We're just stacking those layers. But Z-axis basically just means the height of that layer, to sum that up.
I've seen some pretty interesting marketing messages around plastic where you can see the print layers.
Yep.
And companies getting creative saying, oh, it helps with retention. It's like, does it?
Yeah, I don't know that I buy that one either. I think it's just
creative.
It really, and I know which company you're talking about. We all do, but you know, it's the printing technology that they were using. You know, they've been doing it a very long time, and the printing technology that they were using, you know, didn't have such a smooth surface, and they are printing at a thicker. When you're seeing those layers, it's typically because you're printing at a thicker slice per layer. So, you know, in printing models and maintaining accuracy good enough for retainers and aligners, Michelle, you can print up to 150, even 170 microns and still have the resolution that you need for just a retainer or a liner. But when you print, say if you printed at 170 microns versus a 100 micron model, you're going to see the layers at 170 microns that you will see a lot less layers at 100. And if you print at 50, you're hardly going to see any layers. And then some of the new printer technologies too, you know, have algorithms that help smooth out that outer surface. So we're not really seeing that anymore, but some of the traditional printing technologies, we were definitely seeing the layers. And there's always been a misconception too that you know that big company is 3D printing their aligners. They're not. They're printing models and they're thermoforming over models, and they may be doing it, you know, with robots and a big assembly line, but that is the process. And when you thermoform over a model, you pick up the surface from that model because the thermoforming is very, very accurate. And that's what you're seeing, those layer lines in the plastic. It's not because they're printing the plastic, it's because it's picking up the layer lines from the model.
Thanks for clarifying that.
Absolutely. So when we're talking about the different technologies, there's a bunch of them out there. This is just kind of a snapshot of some of the ones that we used in the commercial lab environment where I came from. You know, particularly, you know, we've used material jetting, you know, and we use FDM. FDM is really kind of the hobby printers that you're seeing if I'm going from right to left. But everything that shows the liquid from SLA on the right to CDLP, that is really the category that we focus on in dentistry. That is what we call vat polymerization printing, where essentially we're taking a liquid and then we're using a light source and we're curing that liquid into a solid layer by layer by layer. So that's the technologies that we're going to focus on today. And there's a few different types of vat polymerization printing, and that's where we'll dive into next. So 3D printing, it's basically when you're looking at stereolithography, which is that what I just explained, which is a container filled of photopolymer resin, which is then hardened with a UV light source. So the difference in a lot of these technologies is really not necessarily the resins, but it's the light source or the energy that we're using to cure each one of those layers. Now there is a difference in some light sources cure certain types of resins better than others. So you do have limitations depending on, you can have limitations based on the technology that you're using to cure that resin. But essentially, if we're starting at the left, traditional SLA, which is going to be nothing more than a laser that's going to reflect off of a mirror, and then that mirror is going to be adjusting to reflect that laser to then trace out the bottom on the bottom of the tank. It's going to trace out each layer. So it's point by point contact. It's literally having to trace out the layer, versus a DLP or an MSLA, which is also known as LCD light source, like your televisions, LCDs. It's going to be able to expose that full layer, whatever needs to be cured in that layer. It could expose, the light source can expose that entire layer at one time. So you could have better uniformity and more, essentially a lot better speed, because we're not having to point by point trace out layers. We're literally curing the layer at one time. So the two to the right are definitely the two that I prefer for dentistry, because I do think that speed matters. We're looking to help doctors be as the most efficient they can be. Can move on to the next one. So this slide is a really good representation of what we talked about here. We're just traditional SLA is going to use a laser, so it's point by point tracing out each layer. It's fine, and it can be really, really quick if you're just printing one model at a time, for example. But if you've got a plate full of 6 to 8 models, you're literally you're doubling the time almost every time, because it's still that same time to trace out each model. Whereas a DLP or an LCD printer is going to be able to, cure that layer in its entirety and then move on to the next layer pretty quickly. So MSLA or LCD works very much the same as DLP. The only thing that changes is the light source. Instead of using a high-end UV projector, it's using a UV light source or light array source. And then the number 2 that you see labeled there, that's basically your LCD screen. So it's a mask. So when the light comes on to cure that layer, the entire light shines. So all of those bulbs turn on, all of those UV bulbs turn on. What the digital mask does is the pixels are always black. It opens up those pixels where it wants that light from below to shine through. So that's how the LCD technology / MSLA technology works. That digital mask opens up and lets pixels shine through, so that light source below shines. So again, 3 different approaches, but all 3 of these technologies are that polymerization. We're taking resins and we're curing them into solids.
So is the LCD printer, is it faster than the other 2?
Now I would say LCD and DLP are very, very similar. They're both fast. And it is because, their ability to not have to trace layers, but to completely shine layers at a time. So a laser, it may take, 20 seconds to trace out a layer that's got a bunch of models on it, like a build plate full of models. Whereas a DLP or an LCD, it's going to cure that same layer in 2 to 3 seconds, because the entire layer is going to shine, and then it's going to move on to the next layer. So yes, that's why those 2 technologies are the technologies that we prefer in dentistry, because a lot of what we're teaching is same day retainers, first day, first tray, when it comes to their aligners that we're working with them on. So let's compare the options that Voxel has. Now, there's still a bunch of different options out there. We carry these 4 brands. We carry them for a reason, and we don't carry anything without long-term evaluation. We have people come to us with different printers all the time. Sure, we'd love to try it. We'll put it in our lab here, and we'll run it for 6 months, and then we'll make a determination if it's something that we want to carry. But this is our current lineup, and there's a reason why for each one, and we'll go over that. So, and as we talk about each one of these 2, I'll kind of give you my highlight. Like, if you gave me one term, one phrase, what makes this printer better than others or really, really good? So at the top, that's what my highlight is. So we'll start with Sprint Ray. We've been with Sprint Ray since day one. They're probably the market leader, and we've sold literally thousands of Sprint Rays. And the highlight with the Sprint Ray is they do have the complete ecosystem. Everything, and part of that is everything that they've done, they are a dental only focused company. So they don't mess around with other markets like audiology and automotive and everything else that you'll see with some others. You know, these guys are dental guys. So what I love about that is every piece of equipment that they do manufacture, every piece of or every new resin that they develop, it's always dental related. And so they've got a great portfolio of products, from printer to wash to scan, and it's all built on around, you know, workflow, you know, leveraging a really efficient workflow. Sorry for my phone ringing in the background. You move on to the next slide. So highlighting there, you know, the next piece of the equipment. So really there's three things that you need to do in printing. You need to print the actual object, and then you need to wash the excess adhesive or the excess resin off of that object to make sure that it's not sticky, because it's coming out of a vat of resin. So you wash the excess off, and you do that with that Pro Wash, and it's a very good machine because you don't have to get your hands sticky. You literally just put that build plate on the top of that device, and it's kind of like a dishwasher. It goes through 2 cycles. It's going to wash the parts. It's going to then rinse the parts with a second vat of IPA, isopropyl alcohol, and then it's going to air dry that part as well. So you're going through all 3 phases. So in a matter of about 10 minutes, hands-free, never had to glove up, you know, you go through that. And that's one of the reasons it's a very good selling product. Everybody loves the wash dry. The ProCure 2, this is their 2nd generation curing box. Big leap from the first technology because, you know, for example, like if we were 3D printing night guards in the practice, you know, the traditional curing stations out there with night guard resin, it would take about 45 minutes to cure a night guard. That particular resin, it just takes longer after you're done printing it. The post-processing is a bit longer. Then ProCure 2 comes out, and now it cures night guard resin. Instead of 45 minutes, it cures it in 4. So
that's a big difference.
It's a huge difference. So if you're trying to turn around same day, you know, night guard, you can do it. You know, you can take that STL file, you can send it to you guys with your, you know, your full contour, the AI night guard design. And it's amazing because you guys spit it back. It seems like within a matter of like 30 seconds to a minute, it comes right back to, you know, to the clinician. And now they've got a print ready file that they can print in a short period of time. But then this has been a big game changer because, you know, when you had 45 minutes of the post cure, that's more difficult to turn that appliance around same day in the office. So this kind of solved that. It cures, you know, night guards in 4 minutes, and it cures models in as short as 1 minute. So even same day retainers, same day, first day aligner, it's been a big deal. So very, very popular device. And then of course, Sprint Ray, you know, because they are dental focused, they've got a wide range of dental resins and FDA approved resins. So, you know, when it comes to somebody who's just going to be printing a lot of models, they want to do night guards, they want to do dentures, you know, this is, and several other things, surgical guides, Sprint Ray is an excellent choice. We can move on to the next one. Desktop health. What if I was to say, what would I highlight about desktop health? I mean, for me, what comes to mind, and just because we use it daily, you know, that is just, it's a professional quality machine. Desktop health is not just dentistry. They are in all segments of, you know, medical segments and industrial segments. But, you know, these are the guys who, you know, formerly in Vision Tech, these are the guys who invented, you know, DLP technology printing. So they've been doing it a long time. They're very, very good at it. And what you're going to get from a desktop health printer is high quality, high precision, and very accurate, fast printing. And they've got several printers to choose from, as you know. The most common one that you're hearing about, people talk about now because it's a big rave, is, you know, the 1 second from the left, the new Einstein printer. You can move on to the next slide, but desktop health uses a 385 nanometer wavelength to cure resins, whereas pretty much almost everybody else in the industry, minus, I mean, just a couple others that use 385, but everybody else uses a 405 technology. There are some advantages to 385. Is it a big deal? You know, I'll let the marketing teams from each company debate that. But again, we try to be neutral, and we're end users as well. But I'll tell you some of the things that I do notice with 385 versus 405. When you're curing any resins that are clear, they don't discolor. 385, just because it's a natural wavelength, it cures things very efficiently, and whether it's a surgical guide or a clear splint or whatever, they maintain their color very, very good. Now you can counteract that with a 405 machine, and most of them do, by slightly putting a blue tint to those clear resins. For example, I'm not sure if you guys can see me very well, but this is a Sprint Ray Night Guard, and you can see it's got a slightly blue tint to it. But that is how they kind of counter that discoloration. 405 doesn't have, traditionally doesn't cure clear materials, and they stay clear. Also, this is, of course, this piece is from their marketing. You could argue this, but the 385 is, has a reputation of being very, very accurate in its printing as well. So, like I said, professional quality. Desktop Health is going to argue that the printers are, the 385 is more efficient and more accurate. Here's what I really, really like about Desktop Health. We are very active in the full arch market. We do, courses all over the country with, 5 different full arch implant organizations. And we print a lot of, all on X full arch teeth. And I really, really love Desktop Health's Flexera Smile Ultra. In my opinion, from everything that we've used so far, it is the best out there for printing teeth. And that's why I say, call us, talk to us. Let's hear about your needs, what you want to do, because not every printer is perfect for everything. Some just do a better job than others. But if you are a full arch person, that's typically where we're talking a lot heavier with the Desktop Health printer, the Einstein, because the resin, it's just strong. It performs very, very well. The shades are very natural, and we just get tremendous results from the Flexera Ultra. So we really love it, and it is 510. I'm not even reading my slides there, Michelle. Sorry about that. It is 510K approved, so FDA approved for permanent use. It's one of only a short list of resins that have been approved for permanent crown use. The other thing that I like, they don't just have one model resin per se. They've got specialized resins. So if you're an office that's just going to be doing a bunch of die and cast type printing with models, they've got Model X, which is an extremely accurate. All model resins are not the same. You can make resins that can be very, very accurate, but that doesn't mean that resin is going to be very, very fast in its printing. There's different consistencies to the viscosity of those resins. So Desktop Health kind of taking it a step deeper, and they say, okay, we're going to have Model X for those that want to print something that's very, very accurate, dies, for example, removable dies. But when it comes to like what we're talking about today, printing models for aligners and retainers, they've developed a resin called Model Z, which is a very viscous resin, low viscosity, and it just prints really, really fast. The printer can go in its up and down action, its mechanical action, much faster with Model Z. And so we're getting model prints, in that 15-minute range with this particular printer and that particular Model Z resin. So moving on, Asiga is, the highlight is it's accurate. It's also a 385 printer. It's a bit more expensive for what you're getting, but it's a completely open system because they're not banking their philosophy on that razor blade mentality, because they don't really make resins. It's a complete open system that you can print any resin on the Asiga. 2 different models. You got the Max UV, which is a small, really, really accurate for those that are just going to be printing small things. Maybe it's crowns, surgical guides, all on X, provisionals. It's just a great open source resin. And if you want the ability to print any resin out there and not be locked down to just that company's resin, Asiga is a great option. And then the Pro 4K is their other machine that is, it's really a lab printer. It's a bigger printer. You can print lots of models on this. It's got a really big build plate. but for having such a big build plate, being a DLP printer, it's extremely accurate. The fact that they're getting a very large print size with 4K resolution. We've got several of these placed out there in the market, but we typically sell these mostly to labs, but it's an excellent printer and it's completely open source. Again, you can I've already stated that, but open source, you can print anybody's resin pretty much. They've got well over 400, probably pushing more like 500 different resins out there that Asiga will print. So, and then last but not least is, this is a printer that we just brought, that we just really started carrying this year. FlashForge is a very large 3D printing company overseas that, has been in multiple industries. They've just kind of come forward with their dental model, and they've hit the market with this printer called the Focus 6K. This is an industrial grade printer. They do have like lower cost versions of their LCD printers, but this is kind of their highest quality, highest grade. And it's a 6K resolution LCD screen, so really accurate, but it's a little bit larger build plate than some of the others. So you can print up to 9 horseshoes horizontally, in as fast as 24 minutes when printing at 100 microns. If you want to print at 150 microns, they give you that option too. If you want to turn around a retainer really fast and print it, in that 14-15 minute range, you can do that at 100 microns. But it's completely open source. It's just a little bit more affordable, but it's got a really efficient software that, you can pull in your raw STL, hit one button, it's automatically going to base it. You hit the next button, it'll go through and set the clip plane, and you can reduce the size of that, which is extremely important. And I'm about to tell you why. And then thirdly, they got a button that you can hit that gives you the ability to just type on the model anywhere you want. So you can label your models. If you're making models in succession that you're going to vacuum form over, so you're going to make this tooth movement number 1, 2, and 3, aligner 1, aligner 2, aligner 3. You can actually identify maybe, a second molar, put the number 2 or number 3 on it. So then now your aligners are identified. That's a great feature because it does, emboss very quickly and easily, and patient identification of the models is pretty cool. So there's basic price points. I mean, the stuff that we carry, it's really kind of, all over the board. It's, the goal is to try to have something for everybody. No matter where you are, if this is your first printer and you're just going to be printing models because you just want to do retainers and aligners, kind of what we're talking about today, the FlashForge is a great option to going all the way up to, I'm going to be doing a ton of full arch restorative stuff, maybe the desktop health. If efficiency is just really key to me, I just want simplicity, and I want the whole ecosystem, and I just want my staff to just to make this as simple as it can be. That's Sprint Ray all day long, because those guys have just really focused on making a very efficient workflow for clinicians and their staff. Because that's the reality. We're not putting these printers in the hands of engineers and saying, hey, go ahead. We're putting them in the hands of employees that never thought they were going to be, turned into a 3D printer technician. That's the reality of it. And that's kind of, that's why we're here. That's why we like to think we're here, because we're the experts. Let us train your staff. Let us help you delegate all of these things. Our goal is to put you in the right technology, but then also for you, the doctor, not to have to worry about this. Let us train your staff. Next slide.
Yep, we're getting some really good questions, but we'll save those for the end, and we're just gonna wrap up with some tips and tricks for you guys.
I've got just a couple minutes left, but you guys definitely want to see this, because if you want to do some in-house fabrication, don't bang your head against the wall. There's some great tips and tricks that we can go over here. I mentioned earlier that we're the exclusive provider of tagless thermoforming plastics. I come from the lab background. At that time, we were one of only 3 FDA approved aligner companies out there, outside of the 2 bigs. We were the only ortho lab that had an FDA approved. So we've been making aligners for a long time. And of course, we were using 3Shape back then as well. Michelle, you'd be glad to hear that was our software of choice.
Love it.
But what I see is, we have some things that happen. Doctors call us and they're not getting the same results when they're doing in-house things as maybe they were with their commercial lab. And it makes total sense, right? There's some things that your staff maybe doesn't know. They don't know these tips and tricks that are going to produce the best aligner, that are going to produce the best retainer. And that's our goal, is to help you with that. So I'm just going to give you a few of those today. So one, I see in a lot of offices, they talk about, yes, I have a vacuum form machine. I'm getting a printer, I have a vacuum form machine. And I always ask the question, is it a positive pressure machine or is it a true vacuum sucking machine? There's two approaches when it comes to thermoforming your plastics. You can have a machine that sucks from the bottom, or you can have a machine that pushes with pressure from the top. It is proven that it is much, much better to have a positive pressure machine than a vacuum former machine. So if you're wanting to do a lot of these in your office and you have the old school vacuum form machine, I do recommend that you look at a positive pressure machine. My favorite, as far as most affordable, most best bang for your buck out there, is the Mini Star. So that would be my recommendation. You can get that from Great Lakes. So second tip would be, pay really close attention to your draw height. This is the difference between in-office and a commercial lab, right? Is in-office doesn't necessarily always pay attention to your draw height. And each machine is, and I'm going to go a little bit deeper into that next, but each machine is slightly different. What people don't necessarily understand about these machines, they assume that it is heating until it gets to a certain temperature, to the ideal temperature, and then it's beeping to tell you, okay, move it over to the vacuum forming. That's actually not the case. These machines don't have thermometers on them, so it's all based on time. But each machine may have a little bit more, a little less power with their heating coil. I'll give you a perfect example. At my old lab, specialty appliances, we had 8 Mini Stars lined up. And then we had a tag on each one, what code to use or what custom time to use, because we had spent the time to calibrate each one and find what was going to give us the best result. Because if one's getting a little bit hotter than the other, you could be overheating that plastic. Okay. So you need to pay attention to that when we sell our tagless plastics. If we say that it's a 25-second or a 30-second heat time, that is a recommendation, okay? Because your machine may need to do it 5 seconds longer or 5 seconds less. So that's one of the first things that you're going to test. Again, if you or your staff has any questions or wants to dive deeper in that, I'm happy to help. Problem solving.
Sorry.
Back up again. Yeah. So one of the most common things is my plastic's breaking, my retainers are breaking right here distal of the cuspid. It's prematurely cracking. It can happen. And the number one reason why plastic is going to break is because you either overheated it or you overdrew it, right? And those are the things that we need to pay attention to and how to control. Another problem is bubbles. When I heat this plastic, the plastic bubbles when it's exposed to heat. And the reason why that's happened is it's probably been exposed to moisture. Okay. And you need to pay attention to different types of plastic. If you're using a polyurethane like Zendura, Zendura is very susceptible to moisture. That's why they package them individually or just in a couple in each pack. Whereas the plastics we carry, it's a PETG plastic. So it's a polyethanol, but it's not nearly as susceptible to plastic. So we can package 25 per package, but we still tell our customers, when you pull the piece of plastic out, you tighten up that package and push the air out every time. You're trying to minimize the exposure to moisture. So ideally you want to keep it in a cool, dry place and control that moisture as much as you can. So you'll notice, if you back up 1 second, I'm going to point out one more thing, Michelle. So that is the same model. Do you notice the difference in the draw height there? So if I'm using the flat base, it's going to draw the plastic all the way down to that base. If I'm using the BBs that are underneath that base, I can control how far the plastic is drawn. So I'm going to make sure that it's not overstretched. Okay. So now you can move on to the next slide where I want to dive in a little bit deeper than that. So you'll notice that first model was really, really tall. And so I buried it into the metal beads there. I don't know a commercial lab in the country. I've never been into a single one that uses the flat base on their pressure forming machines. everybody in a commercial lab setting uses what we call the BBs, or the metal pellets. So, but now being a company that sells a bunch of plastic, and we take calls on this all the time, private practices don't want to use the beads. And I understand, because the beads are messy. They get stuck in the plastic, you have to remove them, then you have to put them back in the compartment, the beads get on the floor. So that's fine. You don't necessarily, you can get away without using the beads, but you need to be really, really careful about controlling the height, the base heights of your models. Because if you have really, really tall models, like that one that was super tall on the left before I buried it to control the draw, if it's too tall, you're going to overdraw that plastic. You may be starting with an 030 plastic that you're overdrawing, and it's supposed to end up in that 028 range, and you've overdrawn it, and now you've got an 024 plastic that's been, overdrawn. It's too thin, and it's not going to be as durable in the mouth. So the way you control that is you just want to make sure whatever software you're using, some softwares export models with 5mm bases, and some you can control it a little bit more. I don't like that 5 to 7mm bases that I see off of some software exports. And you can fix that. You just need to have the ability to, when you put it in your printer software, you need to be able to make a plane cut. Ideally, you're looking for that 2.5 to 3mm base height, of as far as what 2.5 to 3 millimeters, maybe below the gum line at the lowest point, just to make sure that your models aren't too tall and you're not overdrawing the plastics. If you do that, you'll have a much better result. So you can see that model that I have on there is a very low profile model that I printed horizontally. So I know that I'm not overdrawing that plastic, whereas the one to the left I had to bury because it was too thick. So just pay attention to that, because it is the number reason why people have breakage and cracking of retainers and aligners when they're doing fabrication in-house. If you pay attention to that one little thing, it'll be great success. So vacuum forming tips. Moving on to, once the models are done, we're vacuum forming them. If the plastic has cover foils, like the plastic we sell, the tagless plastics, they have cover foils on both sides of the plastic. You want to leave that on. So leave that plastic on. You want to choose the appropriate code. Now, remember, of course, you dialed in your machine, so you know what's the least amount of time that I can heat it that's still going to get me the ideal draw. And a great way to find out if you're getting a good draw at that time is to turn it over on the back side. And if you have that, you want to have a really good 90-degree angle where it sits flush against the base of the model. But making sure you're not overheating it, so choosing the right time. And then the other thing, if you look at the picture to the left, it's heating up, and as soon as the machine beeps to tell me that it's time, you don't want to waste any time. You immediately want to move that out of the way, and you want to push it over and lock the thermoforming right away. I mean, you want to do that within like a second. If you let it start cooling off at all, you can introduce issues like bubbles in your plastic, or just not being as strong as it's designed to be. So you want to do that as quickly as possible. And then the last thing is never cut the recommended cooling time short. I mentioned earlier that these machines don't have, they don't have thermometers. So instead, it's all based on time. So if it's telling you that it needs to cool for 90 seconds or 120 seconds, you need to not cut that short. Why it's important, because if you're ever making aligners or retainers in succession, say you've got 3 to make, and if you cut that short, the cooling element, the heating element hasn't cooled back off to room temperature yet. And now you're starting the next aligner hotter than what it was supposed to start at. So now that heating element is going to get maybe 20, 30, 40 degrees hotter than it was designed to get. And now you're going to overheat that plastic, and that plastic's going to crack on you once it's in the mouth. So it's simple rules. It's basically just kind of follow the recipes. If a plastic says it wants a 25-second heat time and a 90-second cool, don't cut the cooling time short. That we see that a lot. People don't think that's that big of a deal. It is a big deal. It's a big deal because we're not dealing with thermometers and temperature. We're dealing with time. And that if you let that thing keep going, that heating element is just going to continue to get hotter and hotter and hotter, and it's going to overheat your plastic. All right, next little tip. The first thing you do, you take it off. remember you've got the foil on both sides. You just want to do a quick rough cut to kind of just cut it out. And then you want to do a center cut. And there's several different ways. So, but this is just how I like to do it. And then I do a center cut right at the palate. The reason I'm going to do that is because then I use the large wax spatula and I just stick it in the, in the posterior on the lingual side. I just stick it in there just a little bit to create separation there, and you'll see it kind of pop out. And I've got plenty of plastic to play with there, so I'm not scarring the plastic that's actually going to be left there to cover the tooth. And then I'm going to grab that palate area of the plastic where I cut it at that corner, and I'm just going to, with two hands, I've inserted that spatula in there, and I'm going to pull it. And most of the times it just pops right out. Other times I may have to pull it out of that side and then go hit the other lingual side, and then at that point they definitely pop out. If you have an aligner or a model that's not separating right away, quick fix is you just take the disc, the rotary disc, like you see on the screen on the left with those supplies, and you can just create a vertical slit on the distal of that aligner, and that right there is going to be enough to release it. Sometimes it can get just stuck on that backside, but so that's my tips there. Then you're going to take a band cutting scissors, and you're going to just cut with those band scissors, cut that straight trim line, for the aligner. And then I just pick up the Dremel with the red Scotch-Brite wheel. That's just, again, this is just what I like to use. And I just quickly go around the edge of the complete aligner. This whole process, I can do it in a minute to a minute and a half. But what the Scotch-Brite is doing is, you can't push too hard because you're actually melting the plastic, but it's smoothing any of the cut lines that you left from the scissors. But it's also kind of almost with the friction, it leaves a really, really smooth edge. But remember, keep in mind, we've kept the cover foils on the plastic the whole time. I'm trying to show you guys a way to make the most clear, most aesthetic, most beautiful aligners and retainers. And that's the secret. You leave that cover foil on. So you can go to the next slide. And then this was me today. I just took these pictures for this last section of the thing this morning. But the great thing when it's done, the aligner is complete. My edges are smooth. I've felt them with my fingers. I know that we're ready to go. And the great thing about the tagless plastics that we love and carry is that the cover foils easily remove. So I just, in this example for that picture, I got like a scaler and just grabbed it at the edge and started peeling it both on the lingual, and the occlusal. And then I just grab it with my finger and just peel it all the way off. It comes off in one piece, which is great. And at the end result, you've been protecting your plastic the whole time. You haven't been scarring it. You have a really, really thin layer separating the actual plastic from the model. So you're not picking up any of those surface textures from the model. And at the end of the day, what it leaves you with is just a really awesome looking retainer, very aesthetic. That's my experience and what I could share with you. That's as quick as I can do, but that's kind of happy to have a deep dive with anybody who wants to dive in a little bit deeper or need some assistance with their staff. But Michelle asked me to throw out something special for everyone that was attending the webinar. So our website is voxeldental.com. We're throwing out 10% off all resins and all plastics, so all thermoforming plastics, and it doesn't matter what brand. All 3D printing resins that we sell, we carry quite a bit. We do keep them in stock in our warehouse. We typically have next day shipping on pretty much everything that we carry. But if you want to use the code FCW10 for a full contour webinar, 10%. So FCW, we will run that for you guys through September on the material side for the disposables that we carry. So if you want to try any of the thermoforming plastics or anything, there you go. As far as any of the printers we sell, the only thing got a great offer there. Whatever our current special is, whatever the manufacturer special is, anybody that was on this webinar that calls and talks to us, you'll get an additional $500 of free resin on top of whatever specials out there. And if you buy the bundle, so the complete package, I'll bump that up from $500 of resin credit to $750 of resin credit. The only thing I ask when it comes to printers, I want to have a conversation with you. I want to get you on the phone with one of our team to really kind of help you figure out what's the best printer for your needs. Because again, there's not a perfect printer for every situation, but let us help you determine what the best fit is. And you can contact any one of our members of our team, and there you go.
So what I would say is get your phones out. If you want their contact information, just point your camera at the QR code and it'll pull up their information, so that you guys can get a hold of them after the fact. And then, you know what, I'll leave that up for just a second, just in case you guys are doing that. And we're going to move to Q&A. We've got some really good questions that I want to make sure we at least have a couple of minutes to go over. So James, the first one is for you. So STL files provided for vertical printing. What orientation of printing is best for accurate model printing? They said 90 degrees, 45, or flat 180.
That's an excellent question. First off, I don't like vertical printing. I personally will not print vertical because we have large format printers that are, you can just, when I can print something, particularly a model, if I can print a model flat on its base and get a much more predictable result every time, I can do it so quickly and turn it around. I'm printing them in 23 to 25 minutes, and I can do 6 to 9 models, depending on which one of our printers we're printing on horizontally. Some people say they want to do a large vertical run because maybe they want to do an overnight run. So I get it. You just need to be careful about which models you're putting on the build plate. And to answer your question that was up there, I do prefer like a 45 degree. The reason why is I want to get as close to level as possible, because remember, each layer is a foundation layer for the following layer. And if you're in a situation where you've got retrocline, anteriors, or maybe you're missing a tooth. If you're missing a tooth, if you've got a space available because you're missing a tooth, I would never ever print vertical. So that's one tip I could give you is if it's missing a tooth, don't print vertical. But if you insistent on printing vertical, yes, put it at about a 45 degree, and you'll get better results. You just don't want, if you had it completely at a 90, you've got anterior teeth that are just, you're asking the printer to print them in mid-air, because all of a sudden it's having to create a base layer. But if I angle that, it can stair step a little bit. So it has a little bit of a foundation from the previous layer before it prints the next layer. So that would be my answer there.
Thank you for that. Very detailed. And before I go to the next question, if you guys are interested in redeeming either of the offers from either company, Full Contour is offering a free clear aligner design for all new customers, and then all of the 10% off at Voxel for the resin and the plastic, and then their printer discounts. If you scan the QR code, it's going to take you to a quick form where you can put in your contact details, and somebody from either company, depending on who you're interested in talking with, will be reaching out to you guys. All right, next question. What thickness thermoforming material is recommended?
Depends on what you're doing. If you're doing aligners, the most common thickness is 030. So 030 for aligners. And if you're doing retainers, it's typically 040 is the most common. Some people will use an 035. We have a plastic called Tagless Tough that is a really, really strong plastic that we will actually sell for retainers in as thin as 030, but that's kind of rare. Most people are going to be thicker than 030. They're going to be, like I said, 035 to 040 for retainers, and 030 is the most common for aligners. You want something that's going to give you a little bit more flex, not quite as stiff. It's going to help move the teeth efficiently. So my recommendation for tooth movement is 030.
This person said, regarding the plastic clear aligners, how much is the cost and how many units per bag or package?
Yeah, so great question. So the tagless premium, which is what I would recommend for for clear aligners, I would recommend tagless premium 030. So if you go to our website, that's what you'll be looking for aligner movement is 030 in the blue box tagless premium. That one comes with 125 sheets per box. I don't recall, you can see on my website what the actual overall box price is, but but without discount, it breaks down to like a $2.25 per sheet, per tagless premium sheet. So after your 10% discount, you're going to be, well, I guess that's in that $189 range per sheet. But per box, per large box, you're going to get 125 sheets in a box.
Awesome. And then what about warranty or service options for the printers?
Yeah, every printer we sell comes with a 1-year manufacturer's warranty, and then there's options to extend that warranty. The one particular printer that we have is that I mentioned, that new kind of low cost entry level printer, the FlashForge printer. We do offer kind of a extended warranty type option, or basically a hot swap option on that printer. So as well, SprintRay, the manufacturer, offers a hot swap option on the SprintRay printer as well. So we've got a few different options just depending on what it is, but typically they're going to come with a 1-year manufacturer's warranty, and then we have service and extension options as Voxel that we can offer on top of whatever the manufacturer comes with. So
Amazing.
But the last thing I would say about that too, I mean, the kind of thing that's going to make it a little bit different is most other 3D printer dealers out there, pretty much everyone that I'm aware of, kind of pushes back service and pushes back training on the printer manufacturer. To my knowledge, we're probably the only one that doesn't do that. You can still call the manufacturer, you can still call SprintRay, you can still call Desktop Health for any training and support issues. But because that's kind of this is just our ball field, I guess. This is what we like to do. We like to build that relationship. We want to, so any of your, any printer that you get from us, you're going to be trained by our team, and we encourage that your first point of contact for support is a member of our team. We've got a very stable, experienced team that comes kind of from the lab world, and so it's a different experience. We're not just a company that just makes the printer and can show you how to use that printer. Our goal is to really show you how to tie it into your office. We work with great partners like you guys, to find the right design partners, and to help, teach each one of our customers that workflow. And we want you to use the printer. That's the bottom line. We want you to use the printer, and you're only going to use the printer if you've got great partners that are going to kind of cover the training and support and help guide you through your digital journey.
One more question. It's for Full Contour. Where would we find the price for designs through Full Contour? So depends on what you're interested in. If you are looking for a clear aligner design, those range anywhere from $99 for a treatment plan up to $149 for a treatment plan. That does include the one free refinement and free redesigns. Of course, if we do a design and you want to make a modification, you just send it back. We're happy to make a change for you. So the prices just range depending on if you want anterior, full arch, your manufacturing needs, those types of things. So if you are interested, you can reach out to us and we can go over all those different things on a one-on-one call. Okay, guys, we got to wrap it up. This has been absolutely incredible. James, thank you so much for your time and your knowledge. It's been a pleasure as always. Dr. Gabriela, thanks for sharing your knowledge on clinical outcomes and clear aligners. I, for one, have actually learned quite a few things on this webinar, and I appreciate your time. And thank you all for joining, sometimes late in the evening.
Someone just asked a very important question, and I say it's an important question because I get this question. I got it twice today. So it literally comes in every day, but can you print 3D retainers directly? Okay, we kind of talked about it a little bit in the beginning. It's an awesome question because will we be able to print retainers? Will we be able to print aligners? Yes, we're right around the corner from that. But I actually printed my own set of aligners personally that I put in my mouth and wore about 1.5 years ago. So it's not something that's even new. The problem has been, and the materials are safe and they're FDA approved. I mean, or they will be FDA approved. The challenge has been just making a printable resin that's a liquid that is then being exposed to UV and turned into a solid that has the same properties as a drawn plastic. And to this day, I still haven't seen anything that really competes with that, drawn plastic. When plastic is manufactured, like for example, I mean, I know our tagless stuff really well because that's our plastic, but it's almost layered. It's multiple layers of plastic that are then melted into a homogeneous layer. But the fibers are going this way and this layer and this way on in the next one, and it's just kind of basket woven like that. And so you can create some really awesome properties with manufactured, blown, or drawn plastics that I'm just not seeing that yet. The 3D printable retainers and aligners, in my opinion, they're still a bit brittle compared to the elastomeric qualities that you get from a drawn plastic. And secondly, we can't print them as thin as I would like to see yet. Like when I made retainers and aligners for myself, the thinnest we could print that material at for a retainer was 080, which is twice as thick as the normal retainer. So, I question, are we going to have comfort issues as well if we're opening the bite a little bit more with 3D printed resins? But will it happen? Yes, I'm excited to see it happen because there's so many cool things we'll be able to do because we can control forces with how thick we print the retainer, for example, in certain areas. That can all be controlled with software. I'm predicting the future, but that's the ultimate goal of it. But so it's exciting to see that it will happen, but I would not buy into the marketing that you're seeing, because the past 3 trade shows I've been at, there's been companies that are advertising that they're printing aligners and printing retainers. And I'm just here to tell you that that's our job to stay on top of that. And yes, they are, but it's not quite the same yet. We'll get there, but we're not there yet.
Well, Rick said this was highly informative, and thank you to James. Seriously, I mean, you're a wealth of knowledge. I always enjoy conversations with you, so thank you so much. And guys,
Awesome.
this will be recorded. We'll email it out to everybody. Full Contour will put it on our YouTube channel, so if you want to go back and rewatch and relearn, this video will be be to you.
All right. Thank you so much.
Thank
It was
you
a
so
Thank you,
much.
everybody. Have a great
pleasure
night.
being with you guys.
Bye-bye.
Right. Bye-bye.
Bye.
Bye-bye.